This is section 4.2 notes, and we are adding two polynomials in a vertical format. To do in a vertical format, I'm just going to line up the second polynomial under the first one, but I'm going to purposely line up the terms that are like terms. So x cubed is going to go under the 3x cubed. Minus 10x squared under the 2x squared. There isn't just an x up here. So we can either leave a space or put in a 0x. I'm choosing to put the 0x in because we're going to have to use that 0x when we start dividing, which will be the fourth thing that we do. We'll do multiplication, or I'm sorry, we'll do adding, subtracting, multiplying, then we'll do dividing. So I'm going to put the 0x in now just to get used to it being there. And because I'm adding these, I'll go ahead and add up and down the like terms. So adding, if we've got 3x cubed and we add another x cubed, that'll give us how many x cubes? Right, 4x cubes. The cube doesn't change. That's the thing we're adding. We're adding x cubes. So we just have more of them. So we've got 2, take away 10, x squareds. So negative 8x squared. We've got a negative x, and we're adding no x's to it. So we still have a negative x. We have a negative 7, and we're adding 8, so positive 1. So that's adding in a vertical format. I like that method. I'll show you the horizontal format. You might prefer the horizontal format. Totally up to you. So the horizontal format would be where they have the two polynomials added, and they have like separate parentheses for them. You guys have seen that kind of thing before. And when we've got a parenthesis and we need to add stuff, we have to get rid of the parenthesis. So I have to distribute whatever is in front of the parenthesis here. What is in front of this parenthesis? Well, there is a number here. We're adding 1 of all of this stuff. So if I distribute that 1, what happens? Stays the same. Okay, I'm explaining how I'm getting rid of the parentheses. I hope that we know that I don't need them because it stays the same. So once I distribute that, it all stays the same. Obviously, that seems like a lot of extra work that I just did, but I want to make sure that we understand. Ooh, I forgot a squared. Now, when you add in a vertical format, you want to collect like terms. So I'm looking for anybody who is a like term with 9y to the third. So do we see any other y to the third terms? Nope. Okay, so 9y to the third has no friends, all by itself, just comes down. The next thing I'm going to look for is adding a 3y squared. Are there any other y squareds? Oh yeah, that's minus 5y squared. So I just kind of put them in the same like symbol. So I know they go together. And when I add 3y squared and I take away 5y squared, that's a negative 2y squared. All right, and then we've got this negative 2y. And I look for a common term, a like term. We've got a plus y. So negative 2y plus y would be negative y. And then finally, we have a plus 1 and then a minus 4. So minus 3. So both of these achieve the exact same thing. You may choose which method you use. Subtracting in a vertical and subtracting in a horizontal method. So subtraction this time. We need to read carefully. I don't know why they decided to trick me on this. It tricks me every single year when I do the same example every single year. It says subtract 2x cubed plus 2x cubed plus 6x squared minus x plus 1 from 8x cubed minus 3x squared minus 2x plus 9. What goes on top? Yeah, the second one. Just If I hadn't read it, then I would have just assumed the first one was on top. They made me read it. Okay, so we are subtracting that entire second one. So instead of just looking at each individual column and subtract, sometimes that gets confusing. I like to think about this instead of subtracting a number, I like to change it into adding the opposite of that number. Instead of subtracting, I like to make it into plus and negative because I think adding is easier than subtracting. So I'm going to do that. And I'm going to do that by, and I meant to not draw that yet. I'm going to do that by a little rhyme that I have. When I subtract, I draw the line and I change the signs. Draw the line, change the signs. Draw the line, change the signs. That's another thing that you're going to hear me say when we get to division. So all of these things that I'm doing are going to get us ready for division. You're going to be dividing things that look like that. I got you super excited, didn't I? All right, draw the line, change the signs. Now we just add these. So I'm going to add together 8x cubed plus a negative 2x cubed. So that's 6x cubed. I've got a negative 3x squared plus a negative 6. So negative 3 and negative 6 makes negative 9x squared. We've got a negative 2 plus a 1. So we've got negative 1x and then negative 9 minus 1. So that is a, oh, it's not a negative 9. It's a positive 9. Sorry. Didn't copy it right. Positive 9 minus 1 is a positive 8. Okay. And then last example would be if you would like to subtract in a horizontal format instead. And it says from again. So we're going to start with 2z squared plus 3z. And then we're going to subtract 3z squared plus z minus 4. So how do I get rid of the parenthesis? We're going to have to distribute. What am I going to distribute to get rid of the parenthesis? It's going to be a negative 1. So I'll have 2z squared plus 3z minus 3z squared minus z plus 4. And then I'm going to combine my like terms by drawing pretty pictures. So we've got a 2z squared and a minus 3z squared, which gives me a negative z squared. And then we've got a 3z and a negative z, so plus 2z. And then, 4 is all by itself, plus 4. Poor 4 had no friends. Any questions over that stuff? When I was adding, did I ever change the exponents? No. Just be careful. So part of the assignment tonight will be to do just the adding and subtracting portion of the next assignment. Okay, we're not going to get to multiplication today, which is the rest of the notes for this one. So you just need to work ahead on the adding and subtracting. The other part of today is to finish the rest of the bookwork. I'm going to go over how to use our calculator a bunch, and we're going to go over what we know how to do with graphing so far. So this chapter is all about polynomials. We're going to end up graphing polynomials, but to graph polynomials, we have to know how to factor them. We need to know how to divide them. And obviously adding like terms is important, but that should be the easy part. We need to know everything about these polynomials. So we're getting to graph them. This is just a baby step. Here we've got example 4A. To start this, let's review what we talked about yesterday with the end behavior. Remember, we stood up at the end of class and we did some dancing, right? Okay. So end behavior. To do end behavior, we need to find some things first. Amy, do you remember something I need to find to figure out the end behavior?
Like the infinity.
That's the end behavior. Do you know what I need to find first to know the infinities? What's the first thing that we did? You guys can look back in your notes. F of x is there. What do I need to know about f of x?
Oh, no, it's the degree. Sorry.
The degree, right? Oh, shoot. Amy, while I'm erasing this, can you tell me the degree of this one?
3.
Good. The degree is 3. And from that, what do we really care about it being 3? We care that it is odd. Good. And then there's something else that we have to find. Jackson, can you tell me the other thing we have to find? No, not type. We have to do that for other things, but not for the end behavior. Jacob, what were you going to say? LC. And what's LC stand for? Do you know? Leading coefficient. Leading coefficient. Okay. So the LC, the leading coefficient, is what number, everybody? -1. But I don't really care that it's -1. I care that it's what? Negative. That's what I care about. Good. So from that information that it is odd and that it's negative, we can determine the shape at the very ends of the graph. I don't know what's going on in the inside, but I know the very ends. And anytime it's odd, I think about a line. So I imagine that line, and then I imagine it being negative, so I flip it. On the left and on the right, let's see, a line would normally be like this, but I'm going to flip it. So on the left, it'll be up. On the right, it'll be down. So that's the end behavior. So if we were standing up, we would, I would tell you guys odd, and you go like this, and then I'd say negative in front, and you'd go, right? Okay. Now, let's use our symbols to write that. Remember, we always go left to right, and we talk about it going up to down. That's what we talk about. So in my head, I'm thinking up to the left. So up to the left is saying that the f of x is going to positive infinity. To the left means as x goes to negative infinity. That's up to the left. Up is f of x, the y values. Left is the x values. And then the second thing we're thinking about is down to the right. So down to the right, I'm going to write in symbols. F of x is the y value, so that's down, and down means negative infinity. As x to the right is positive infinity. So that would be the end behavior. The part in black, not the part in pink. The part in pink is like what I'm thinking. You're more than welcome to write it down, but the part in black would be the part that I would grade. Okay? So when I'm done graphing this, I should have ends that do that. Now, we're going to graph some other things that we have been doing since the very first lesson that we did in here. We're graphing some other things that we've been doing since the very first lesson. What else have we been graphing every single time, no matter what the graph is? Every single time I've asked you to find these things. What?
Is it the y-intercept?
The y-intercept is one of them. How do we find the y-intercept? We're going to do plug 0 in for x. So I'm going to write f of 0. And then everywhere I see an x, I'll make it a 0. So it's like -0 cubed plus 0 squared plus 3 times 0 minus 3. Is that what it was? I'm trying to go off memory. which is going to give me -3. And that's a y-intercept of 0, -3. And I'll go ahead and plot that because I know that's a point on the graph. I found it. What else have we been doing this whole time? Y-intercept. And what, huh? The x-intercepts. When we graphed lines, we found both. When we graphed quadratics, we found both. When we graph polynomials, we find both. I'm going to put the x-intercept stuff over here. Okay, to find the x-intercept, what do we do? Plug in 0 for y, right? Here's a bonus question. How many should I get? What do you think? It's going to be 3. The degree is also how many solutions, how many x-intercepts I should get. So I should get 3. Okay? Now, let's see. We plug in 0 for y. We get -x cubed plus x squared plus 3x minus 3. So in our chapter on quadratics, when we learned how to solve equations, we learned lots of different ways of doing it. We learned by square roots. The square root's not going to work here. Because first of all, it's a cubed, right? We learned complete the square. That only works for quadratics. We learned quadratic formula. Guess what? Only works for quadratics. We're left with 2 ways to solve this. Graphing. Well, we're just starting to graph it, so we're not going to solve it by graphing. Or what's our last way that we've been practicing a lot? Factoring. We're gonna solve this by factoring. So we go through our steps of factoring. What's the first step of factoring? Is there GCF in all 4 terms? No. Remember, for factoring, I have it open here. After we check for GCF, then we have to determine how many terms it is. I think I just said for all 4 terms. So it's 4 terms. So we're going to factor by grouping. Let's factor by grouping. Yay. Oops, wrong one. Factor by grouping. So group them together, plus sign in the middle. What factors out of the first parenthesis? I could take x squared out, but I'm actually going to do something else. I'm going to take out the -x squared, yeah. If there's a negative, I like to take it out. And then what's going to come out of the second one? 3. Okay. So we take out the -x squared, we get x minus 1. If we take out the 3, we get x minus 1. All right. And then remember, our next step is we look at this and this separately, and we say, is there a greatest common factor in those 2 things? Yes. There's an x minus 1. So we're going to factor that out. And I'm going to have left over -x squared plus 3. -x squared plus 3 is not linear. So we want to keep going with that and make sure that it can't go further. So when you have a binomial left over after you do factor by grouping, the next thing says check all binomials for difference of squares. So we need to see if this is subtraction and if everything's perfect squares. We need to check that. So if I say is it subtraction and you say no, I'm going to rewrite it. So I'm going to say, is it subtraction? And you're going to say yes. Is everything perfect squares? No. Okay, so it's factored anyway. So if it's factored, how do we solve? How do we solve it now? We need x equals. How do we solve it? X minus 1 equals 0, and the other one equals 0. So we set each factor equal to 0, and we solve each individual factor. So this one, x equals 1. All right. The next one, I'm going to add the x squared to the other side, so I'll get 3 equals positive x squared. And then what do I have to do next on this one? I have to what? I have to what? Something else besides square root. I have to plus minus square root. So I get x equals plus minus square root 3. Can we simplify that square root 3? No. So we get 3 x-intercepts, which is what we needed. 1, 0. We get negative square root 3, 0. And we get positive square root 3, 0. I didn't put them in order. I meant to, but it didn't happen. Let's use our calculator just to find out what square root 3 is approximately. You guys know how to type in square root 3 on your calculator? Yes or no? Do we know? I mean, I got to show you if you don't know how. Mine's already done. That's why I'm asking you if you guys know how. So if I'm going to graph it, I got to type in square root 3. Oh, it's approximately 1.7. I mean, I'm not going to be able to get very accurate. So 1.73, not going to be able to graph it that accurately. So about 1.7. Keep holding on to your calculator because we're going to use it in just a moment. So these points that I just found, 1, 0, about 1.730, and about negative 1.73. Those are some x-intercepts. We know that this end has to go up, and we know that this end has to go down. How do I know that? How do I know? What's it called? What was I calling it? We did find it earlier. I drew a little picture. What? End behavior. Actions is kind of the same thing. The end behavior, how the ends behave, yes. So I know that right now about it. We're going to kind of use our graphing calculator to fill in the rest, but if you can see how those could possibly connect, you might have a rough idea of what we're looking at already. Well, we'll go ahead and use our graphing calculator. So go to your graphing calculator, go to y equals, and type in the equation. I have 2 things typed in mine because I already typed in the second one, but my y2 is your y1. I typed them in a weird order. So you guys are typing in negative x cubed plus x squared plus 3x minus 3. If you have questions, you should ask. How to type something in? Ask so I can help you make it easier. If you're using Desmos right now because you didn't bring your calculator today, that's fine. You can't use Desmos on a quiz or a test. So at least follow along. I'm going to teach you a few things about the graphing calculator, but I'm making a video so you can go back to it and view it later. And we're a little bit short on time, so I'm going to go as quick as I can, and then you can go back to the video later. So when I hit graph, this is what it should look like. All right. If you would like to find some more accurate points, one place you can go is the table. To get to the table, it is right above the word graph. So you have to do second graph to find a table of values. And in this table, you can, go up and down, and you can get more points to plot to make it more accurate. So I've got negative 2, 3, negative 1, negative 4. Let's see. Negative 2, 1, 2, 3, negative 1, negative 4. I think there was another point in there that 2, negative 1. Okay. I found some points that I could graph. Yes.
Does the number of x-intercepts have anything to do with how many different dots we have to have plotted? is it a 5 like with quadratics?
So right now, since we have a graphing calculator, you could just make it pretty accurate, okay? Because I just showed you, first of all, I just showed you how to get any points. I'm about to show you how to get more points, okay? So there isn't like a minimum thing for this. Later, when we're actually graphing them, you'll understand how much you need at that point. But you should be able to find the y-intercept. And on some of these, you'll be able to find the x-intercept. Forceps. Okay. Another thing that you can do when I go back and look at the graph, I'm going to use my finger to point, but you can't really see it on the video. So I put my little cursor there, but in class, I'm using my finger. You guys see how there's this little point that goes down and then it comes back up again. When we have something like that with quadratics, there's only one of them and we call it the vertex. And then we started using a word like minimum because it was the lowest point. And then for the other one, that other top right here, if it was just a parabola, we'd only have one and it would be called the maximum because it was the highest point. But when we have higher powers, higher polynomials, degrees, that is not the highest point or the lowest point because the highest point is infinity. It goes on forever up there. And the lowest point is negative infinity. It goes all the way down. So this is it's called a relative max or a relative min. So I'm going to call them mins and maxes, but they're not minimum and maximum of the whole graph. It's just in this area, there's a minimum. Okay? So just in this area, there's a minimum. Your calculator will tell you that exact point. You just have to know how to ask your calculator nicely. Okay? Now, your calculator does not read brains, and it's not a living, breathing, thinking being. So you have to be specific on what you tell your calculator. So this is what I'm going to teach you now is how to ask your calculator to give you information. So most of the things you're going to want to get information on graphs are under the calc button, which is second trace. So let's go second trace. And I was just saying some of these words. What do you think I'm going to choose? Minimum, and then later I'll come back and do maximum. So to get minimum, if you just hit 3, it works. If you want to arrow down and then hit enter, you can do that too. Now, your calculator will ask, let me move this out of the way. Your calculator will ask left bound. So your calculator does not know what you want. It can't read your mind. It's just saying, all right, if you want a minimum, where do you want me to look? In what boundary do you want me to look? So I'm pretending my finger is right here on that. I'll put the arrow there as well. I'm putting my finger right here and I'm saying pick any point that is to the left of where my finger is. Pick anything that is to the left. I'm not saying up or down. I'm saying to the left. So give me a number that is to the left of this. -2. Yep, that's to the left. So what you're going to do is you're going to type -2. And as soon as you start typing, something comes up down here where you can type it in. And then you hit enter. And my calculator draws a line. And it says, I need more information. Tell me something to the right of this minimum point. So pick a number that's to the right. Give me a number. I could not hear answers. 2? How about less? I mean, 2 will work. I was thinking 0, but it doesn't really matter. 2 will work. I'm up to 0. Okay, so now there's a boundary, and then your calculator's like, just to make sure we're on the same page, approximately where do you think it is? So it doesn't have to be super accurate. Where do you think, what X value do you think this is at? Close to. Don't be super accurate.
24.
X value.
Oh, 27. 1.
How about just -1?
Yeah.
-0.7 would have worked fine, but I'm going to make it even easier. -1. All right, there it is. That's the one we were looking for. So we've got -0.7, -4.3. So on here, I can, graph this. What I say, -0.7, -4.3-ish. I was writing it down so I didn't forget. -0.7, -4.3-ish. 4.3-ish. 0.7, -4.3-ish. 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 0.7, bottom point. And then I can start connecting. And then I just got to find that top point. So I'm going to do the whole finding minimum or maximum thing one more time. So now we're going to find this maximum point. So we're going to go back to second trace, and I'm going to choose maximum 4. It's going to ask me the same questions. Left. So I'm looking in a different place. What's to the left of this guy? 0? Okay. So 0, enter. What's to the right of where? Huh? 2? Okay. So we've got a boundary, so it knows where to look for your answer. Could we just like make a guess, make it a little bit easier on it? Knows exactly what we're looking for? 1. Okay. All right, so we have an answer, 1.4 and 0.4. So 1.4 and about 0.4. Gosh, how accurate can I really be? And now we have a nice looking graph of what we saw in the calculator. What about what we just did? Because I'm not going to have time to do that last full example. This is the last one that I did in my other class. What about the example that we just did? Did you find confusing at all that you feel like you would want me to go over in the last couple minutes? Or should we just graph the last one and see what it looks like? Well, let's do the end behavior. Let's do the end behavior. What's this one going to be? What do we got here? Degree, 4th. Even, thank you. And then, what's LC? What is LC? Leading coefficient, which is 1, which is positive. That's what I care about. So when I graph this, when I have anything even, I think about a parabola. Parabola is even. So we know it's either up, up, or down, down. And then we look at positive and we know that it's up, up. Okay. And behavior for this one would always start with the f of x, and it's going up, so that's positive infinity. And it's going up to the other one as well. So both of them are going to start with going to positive infinity. The top one is always as x goes to negative infinity. The second one is always as x goes to positive infinity, because it's always left to right. All right, go ahead and graph that on your calculator just so we can see at least that we were right on that aspect. We didn't have time to do all the other fun stuff. And I have mine already typed in if it takes you too long to type it in. Can you see any y-intercepts when you graph it? And you can look up at mine if you don't have time to type it all in. If you're a slow typer, you can look up at mine. Do you see any y-intercepts? 4. Yeah, at 4. You see any x-intercepts? At 1. That is one of them. How many x-intercepts should there be if it's a degree of 4? 4. We see 2. You know what that means? The other 2 are imaginary. We don't have time to finish that one, but that's okay. You guys now can finish the first assignment, and then you're just doing the adding, subtracting part of the next assignment. If you feel like overachieving, you should already know how to multiply, you know, the window method or box method or distributing. Like, you should already know that stuff. That's what we're going to do tomorrow. All right. Ethan,